Hey guys, this is just a quick showcase and tutorial of how to use the TM1637 4-digit LED display with a Raspberry Pi. What you're seeing right now is just a basic scrolling function I implemented on top of an existing Python library. If you want to use the Python library and or read a quick tutorial on how I set up the hardware and software, check the GitHub repo in the description. If you're interested in how to create some of your own additional functionality with the TM1637, or just learn how the display operates in general, I'll also be covering that in this video. I still urge you to check out the GitHub, since almost everything I cover here is written down there as well for quick access. Anyways, getting into it now, writing data to the display isn't as complicated as the datasheet may make it seem. First off, let's get a basic understanding of what values we want to be writing to the device. The TM1637 takes a single byte of data for each individual 8-segment display, 7 plus the decimal point. The diagram on screen now gives a brief rundown of what each binary digit of that byte corresponds to on the display itself. Once again, I recommend checking out the GitHub repo if you want to look at this diagram as you figure things out. To give an example, let's say we wanted to display a capital L. We would want to light the segments D, E, F, which corresponds to the 3rd, 4th, and 5th binary digits. Thus we get the byte 00111000, which maps to the hexadecimal value 38. Therefore, if we write 38 as the data value to a display, we get a capital L. Now, if you want to understand the actual operation of the TM1637, the easiest way is to start with auto-increment mode writing. This is the approach that the show function of the library uses. Here's what the datasheet shows. To break it down, we are first going to start the data transfer. Now, when I say start, break, stop, or write in this explanation, know that I am referring to the library functions. They handle actually setting the pins to low or high properly, so I'm not going to concern us with those specifics in this video. However, if you need to know, just go look at the functions and it's fairly straightforward how they work. If you are trying to translate it to work in another language, it should be pretty self-explanatory. Back to the operation now. After we start the data transfer, we are faced with command 1. Command 1 handles setting the mode of this data transfer. We are going to write hex value 40 to signal that we are writing data to the display register. After that, we break, which is just a stop followed by a start. Next we have command 2, which corresponds to the address you want to write to. C0 is the first address, and since we are auto-incrementing, we will start there and just increment to the end. Thus we write C0 as this second command's value. Now we are presented with writing the data for each digit. Earlier we figured out that if we write the hex value 38, we will get an L. If we only wish to write an L in the first display digit, we simply write the byte 38 and then 3 consecutive bytes of 00, which result in nothing being lit. Lastly, we break once again, and then are presented with command 3. Command 3 corresponds to the control of the display and its pulse width. That means we can control the brightness here. A larger pulse width will result in a brighter display. As you can see, the byte 88 ensures the display is on. The last 3 binary digits of this byte control the brightness between the values 0 and 7. Therefore, if we want a brightness of 2, we simply add 2 to our 88 and get the byte 8A. After writing that, we just stop our data transfer, and that's all. That may have been a lot to take in, so for a quick recap ignoring the specifics, first, we write our first 2 commands to signal that we are writing to the displays from first to last. Second, we write out the bytes for each digit to display. And lastly, we write out command 3, which is just the brightness value. If you're still looking for more, I recommend checking out the show function from within the library and matching it to this explanation or the explanation on the GitHub page. After that, you can take a look at the show1 function to see how writing in fixed address mode works. If you can piece all of that together, you should be able to do just about anything you can think of with the TM1637 displays. Once again, everything touched on in this video is on GitHub as well, so if you just need a quick reference, I highly recommend checking it out. There is also a quick guide to setting up the library and the hardware if that's something you're interested in. That's all for now. Best of luck.